Okay, we are in our third lesson from the very important chapter 1. It's once again important that we take the time to get to know chapter 1 inside and out, because the rest of our experience, whether it's just in pre-calc or if you go on to calculus, is going to be better if we can have that solid foundation. So here we go. Function notation and graphs. We're talking about interval notation last time. Function notation this time refers to the idea of expressing, instead of saying y equals 3x plus 2, function notation expresses it as f of x equals 3x plus 2. And there's a lot of great reasons to use function notation, and we're going to talk about that today. So here we go. The first thing I want you to be aware of is when you see f of -1, that's referring to what's the value of the function when x is equal to -1. Another way to say that is, hey, what's y when x is equal to -1? So when x is equal to -1, y is 7. So I don't know if you're noticing that when we look at graphs, we're really just looking at the value of y at certain x points, at certain points in time in the graph. And so f of 0 just means that what's the value of the function when x is equal to 0. We go to x equal to 0, we see that it's 5. So once again, something basic like this seems like, why am I going over this? Well, because past students don't have this down, and then they get very confused when we do more difficult things. So good for you if you remember this from Algebra 1 and Algebra 2. All right, function notation with equations. How are we going to use that? When we see f of -1 and we're given, oh, my bad, this should not say y equals 3x squared minus 2x. Shouldn't it say something like, let's give it some thickness here, f of x, okay, that was a little too thick. All right, let's keep going. So yes, why didn't I put f of x equals 3x squared minus 2x? That's silly. All right, so here you go. F of -1 says, see this function? Now find the value when x is equal to -1. So what I'm going to do is I'm going to rewrite the function. Every time I see an x, I'm going to put in a -1. And then I can either pick up my calculator, or I can say -1 squared is 1, 1 times 2 is 3. Oops. Okay. I think doing 3 videos in a row is a little too much, but I'm going to try to keep it together for this one. So here we go. -1 squared is 1, 1 times 3 is 3, -2 times -1 is 2, so 3 plus 2 is 5. All right, so let's do the next one. If we're going to plug in 0 when we see x, right? Oh, it's going to be 0, isn't it? All right, and if we plug in 1, we're just going to do this in our head. So we plug 1 in, we've got a 3, minus 2 is 1. And then if we plug in h, oh, you're like, wait a minute, I didn't know we could do that. All right, let's talk about plugging an h in. It feels weird when we're not plugging a number in, but basically what we've been doing each time we're plugging in a value is, it's like we're taking this x and we're actually like picking it up and we're throwing it across the room. I mean, gently, and it's landing on something very soft, okay? It was fun. But you know the idea. Just take that x and throw it away and replace it with, in this case, an h. All right, so we're replacing it with an h. Same thing, we're going to write that minus, and we're going to write that 2, and we're going to take the x, throw it away, and replace it with an h. And the only thing I can do is just make it look better, right? It's 3h squared minus 2h, and that's it. I can't do anything else with it. All right, so let's look at when we're looking at x plus h. And you wonder, why are you making us do this? Well, we do some work with x plus h in calculus, and so why not just look at it now? So here we go. We see a 3, we write a 3, right? But we see the x, we take the x, we throw it away, and we replace it with x plus h. That's weird, right? We took an x, we threw it away, and then we're replacing it with another x? But it's not really an x, it's x plus h. And then, of course, whatever was happening with x was being squared, then x plus h gets squared. And then here we're going to write, we see the minus, we write the minus, we see the 2, we write the 2. We see the x, we throw it away, and we replace it with x plus h. Now, could we stop and spend a lot of time expanding x plus h, the quantity x plus h squared? Sure, we could distribute the -2 as well, but you know what? That's just kind of silly, because honestly, answers in factored form, which this is, they're good, and we're going to stop there. All right, so I know this is review from Algebra 1. This, if you saw an Algebra 2 trig, you might have just seen it for just a little hot second. So this is going to seem new, but piecewise functions are really important. We do a lot of work with them in calculus, and they make sense for real-life applications, actually. So let's get used to what this even means. So this says the function f of x equals to, well, wait a minute, there's two rules, right? F of x is equal to 3x, but only if x is less than or equal to 1. But if x is greater than 1, f of x is equal to 5 minus x. So it's like there's two conditions here. So before you know which function to use, or which part of the function to use, or which piece, of the function to use, you have to know what x is. So when we're looking at these questions, f of -1, we're like, oh, okay, we're looking at for the value of the function when x is equal to -1. Which rule should we use? Well, we're going to focus on, I don't really like using red here, we're going to focus on these two conditions, okay? Which one works for -1? Well, -1 is less than or equal to 1, so we're going to use this rule. So we're going to go ahead and plug in -1 when we see the x, and we know that for this function, when x is equal to -1, the value of the function y is equal to -3. All right, let's do that again. So when we see we're dealing with x is equal to 0, we're like, okay, which one? Which one? Oh, we're still using the same one, right? We're going to use this one. X is, when x is equal to 0, it's less than or equal to 1, so we're going to use this rule. We're going to plug 0 in for 3, and we're going to get 0. F of 1, which rule? Oh, the same one, right? Because 1 belongs with x is less than or equal to 1, so we're going to use the same rule of 3x, and we're going to plug in not a 0 again. We're going to plug in a 1, and we get 3. All right, finally, we get f is equal to 2. Okay, 2 is greater than 1, so that means because 2, when x is equal to 2, it falls under this constraint, then we're going to use this rule. So we're going to go ahead, and when we see that x, we're going to plug in a 2, and we're going to get 3. Same thing with 3. 3 is greater than 1, so that means we're going to use this rule, the 5 minus x, and we get 2. All right, that was your first little review, or maybe for some of you, the first time you've seen a piecewise function. We're going to do more with it in just a second. All right, we're going to graph it. And I think a graph's really important because you can kind of visualize what we're even talking about with a piecewise function. I think having a visual in math is super important, especially for, most of us are visual people. All right, so here we go. We are going to split this graph into two different steps. All right, so here we go. Step number 1 is we're going to make a table. We're going to make a table first for this top piece right here. All right, so we're going to take this piece, and this table is going to match with it. And we have to remember our constraints. X has to be less than or equal to 1. So let's put 1 up there first. Now, we already did plug in 1. We already did this stuff. So let's just fly through it. When x is 1, the value is 3 times 1, which is 3. Now, I can't put a 2 here. X has to be less than or equal to 1. I could put a 0 here. When x is 0, y is 0, right? Because 0 times 3 is 0. X can be equal to -1. 3 times -1 is -3, et cetera, et cetera. Let's do one more. X equal to -2. That's going to be a -6. And we come over to our graph, and we would just graph it, right? So over 1, up 3, that's good. 0, 0, -1, -3, and -2, -6. So that is one piece of our, in fact, let me go ahead. We can see that it's linear. Obviously, 3x is a line, right, with a slope of 3. So we're going to go ahead and connect our dots, put an arrow. We're going to make sure this is, we see that, we stop when x is equal to 1 and y is 3. All right, whoo, we're done with half of our first step. Let's go ahead and switch colors. And now let's make a table for our second piece of our piecewise function. Now, here's the deal. See how it says that x has to be greater than 1? Well, I'm not going to start with 2. If I put 2 in my table, I would leave out 1.1, 1.4, 1.99999, right? I'm sorry, I wouldn't be. Yes, I would be. I would be leaving all those out. Sometimes, you say something, you have to just stop and listen to what you say. It's like, okay, yeah, no, that was right. All right, here we go. This is definitely my last video in a row. I just, this is during the pandemic, so I'm up in my classroom before school starts, and I'm trying to get as many videos done as possible, and I'm learning 3 videos in a row is pretty much my limit. All right, so here we go. We're going to get through this. We're not going to put, we are going to put 1. If we put 1 in for x, I get it. X can't equal 1. And that's why I put this dotted box around there. But for this part of our piecewise function, when we get to the piece that doesn't have the equal to sign underneath, we are always going to do this dotted box, and we're always going to start with this number. We have to have a placeholder. So here we go. When we plug in 1 for x, 5 minus x is 4. We're going to go right over here, and we're going to plot this point so we don't forget. Over 1 up 4, that's a placeholder. We're going to put, you know what, I'm going to use a different, let me go back and see if I can use a thinner, there we go, let's do something thin so we can really see that's an open, there we go. I'm going to use that open hole at the point 1 comma 4 to show you that's just a placeholder. And you'll see why in just a second, why we needed that. All right, so here we go. Let's plug in a 2. 2 is fine to use. 5 minus 2 is 3. Plug in a 3. 5 minus 3 is 2. And plug in a 4. 5 minus 4 is 1. So let's plot those points. We've got over 2, up 3, and over 3, up 2. And of course, this is a line, right? We could have graphed this just knowing that it's a line with the slope of -1. So we're going to go ahead and connect this. Okay. This is our piecewise function. Now, let's stop and remind ourselves why we needed that open hole. All right, let's have this conversation real quickly. If we didn't have that open hole and we started with x is equal to 2, we would miss out on all of this part of the graph, right? These are all the y values for when x is between greater than 1, obviously, and less than or equal to 2. We'd miss out on all of them, all right? Or less than 2, because we'd still have that part there. Oh, don't you love it when the eraser just erases everything? All right, so that's why we needed that placeholder. I'm going to quit talking. I'm going to talk basics, okay? I know I'm going to quit talking conceptually. I'm going to talk basics. Here we go. Piecewise function. You see, I would always start with the table with the one that has the equal sign underneath. I would put the whatever number is there first for x, and then I would keep following and plot it. My second table, I always am going to start with the number that I see on the opposite side of the greater than or equal to sign. I'm going to put it there, but I'm always going to put these dashes around to remind myself this is an open circle. Okay, we are going to leave a hole there in the graph. That is our place holder. All right, so those are the 2 things that I think people get confused. All right, let's do one more of these. I think that's all we've got. Yay, one more. All right, so we're going to do the same thing. We're going to start with this one because it's got that equal sign. We're going to put this number for our first 0. We're going to plug it in. 3 times 0 squared is 0. 0 has to be less than or equal to 0, so we're going to plug in a -1. That's going to be 3. Plug in a -2, and that's going to be, what, 12. That's enough, right? Let's go ahead and graph it. 0, 0 is a filled-in circle. Then we've got -1, 3. So 1, 2, 3, and -2. No wonder it goes up so fast. We're looking at quadratic, so we're going to give this part of the graph a little curve if we can. Curve, 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 curve. Okay. You know, our little sketches don't have to be perfect. All right, so here we go. Here's the big part. I see that I have a greater than. There's no equal to. I'm still going to take this 0 and I'm going to throw it in for my x. But I'm going to put that darn dotted box around there to remind myself that this is an open circle. So here we go. We're going to plug in 0. 4 times 0 is 0. 0 minus 1 is -1. I'm going to go put that in right now. 0, -1 is an open circle. Let's figure out the rest. X has to be greater than 0, so we put a 1 in. That's what, a 3. Put a 2 in. That's a 7. That's enough. All right, let's do 1, 3. So over 1, up 3, and over 2, up 7. It's linear, so we don't give it a curve. Now we have to remember we have to start from that open circle. There we go. All right. Is this a function? Absolutely. Oops, I made it kind of curve out there, didn't I? If you did the vertical line test, you would see that. Definitely is still gave the curve. Okay, you know my intentions. It's supposed to be a straight line. If you did the vertical line test, it's a function. That's why it's especially important to have that open circle here. Otherwise, we'd have two values for y when x is equal to 0. All right, you're going to get plenty of practice with this. Thank you for joining me. I'll see you next time.